Hey everyone, it's Jim
And Charles.
from Mellow Amps. And in episode 20, we're going to do a little episode on switch renewal. And we'll talk a little bit about switches. But first, caution everyone, electronics and tube amplifiers can have very high voltages present, which can be lethal. Exercise extreme caution when working around them. Always consult a professional technician when in doubt. Okay, when we think about what components make up a preamp or other piece of audio gear, it's easy to think resistors, capacitors, vacuum tubes, and or transistors, transformers, PCBs, hookup wire, and a chassis. But one key component that often has the signal passing through it is the switch. And even high-quality switches can develop resistance over time, which can either lead to a drop in supplied voltage, or in the case of the audio signal, a degradation in sound quality.
I think this is actually a fairly common issue with vintage equipment as well.
Very common. Now, most modern switches aren't serviceable. In fact, here's an example of a double pull, double throw, so that's a DP, DT switch. That's the MTA, let me see if it'll focus, there we go, workhorse for switching input signals and other low-power tasks. In fact, believe it or not, this big monster down here, which is out of focus now, has the same functionality as this switch, but this has much, much higher ratings. In fact, this little double pull, double throw switch is rated at a maximum AC and DC of 28 volts, and it can handle a total of 0.4 volt amps.
So it's really only good for very small power tasks or switching signals, which is what we mainly use it for.
Yeah. It's a beautifully made switch, though. The specs on it are excellent. It's not cheap, but you know, good components aren't cheap. So it's well worth investing the money in that. Now, in our classic line, all of our switches are point-to-point wired, and that allows for a heavy-duty switch to be utilized, and many of these larger switches can easily be serviced. Here's an example of an actual switch that we use to switch the input signal on our classic line amps. It's a double pull, double throw, just like this one here. In fact, you can see that we've got 6 contacts, and we've got 6 contacts. And just in case, I'm just looking for a pointer here, just in case you're not familiar with what contact is what, in a double pull, double throw switch, you essentially have 2 switches inside one envelope, just like we see a lot of twin triode vacuum tubes, which 2 tubes inside one envelope. So on one side of the switch, we have one switch. And on the other side, we have another switch. Now, they're actuated at the same time. So when you hit the switch, both switches work in unison, which is why it's such a useful and valuable switch. The common for the switch is here in the center. And we're going to tear this down in a minute, so you'll see that. And the in or out contacts are at this end. And this type of switch, because of how it's actually designed and manufactured, when the batten is pointing this way, it's actually actuating this end of the switch. So this set of contacts and this set of contacts here, the center ones, are on, and when it's in this position, it's this pair back here and this pair in the middle, again, the common. And in this case, this switch actually has a détente. It's a fancy French word that just means fuck all. I mean,
I don't know if you can see that on YouTube. We'll see what happens with the video.
Yeah, maybe we'll get censored. So in the center, in the détente position, nothing's happening. The entire switch is basically disconnected. So let's get some tools on deck here and put away this expensive switch, and we'll do a little tear down, and I'll show you how you can easily renew one of these switches. And there's this style of switch is very common. There's a lot of them out there, particularly in the DIY world. And
they make them in all sorts of different arrangements too. Single pole, double pole, triple pole. I think there's even quad poles out there. There's tons of them.
Yeah, and if we get a note or a bunch of notes saying, could you please explain what these poles and all this are about? Absolutely. We'll do a video. We'll bring a whole bunch of switches up and we'll show you what, in fact, those designators mean. But for the moment, I'm going to presume that you can figure it out. And we'll just take a look and we'll see if we can actually renew the surfaces or the contacts of this switch and make it basically brand new again. Okay, we'll see you back in a minute. Okay, so let's just start by opening it up. There's always a tab on each end. And you can, if you have a little slot screwdriver, that's the easiest thing. So just go ahead and sneak it in and under there. And just bend that up. Sometimes it takes a little bit of work to get it up.
You don't really want to lever that out on a hard angle too much there, because then you'll have to bend it back. It'll work hard on the metal. So just bend it enough to get it over that lip.
Yeah, that's right. Okay, now, whenever you take anything apart, and hopefully you learned this rule back when you were maybe 4 years old and tearing things down, and after you tore apart something, realized you had no idea how it went back together again. Follow mechanical engineers follow a very standard rule, and what they do is they take things apart in a logical sequence. And I learned this from an auto mechanic, a master mechanic. So that came off first, so we're going to put that over here. And of course that fell out. And actually we're going to get a little working surface underneath us so that we don't muck things up. I'll be right back. Okay, so that came off first. This came off second. This popped out.
So we're going to call that third.
And it happens. Things do go pop. And whenever you're working on something that has contacts and things like that, make sure, sorry about the lighting folks, it's just a little tricky to get into dark corners with a light. So in fact, even when we're working on the bench with something that's really tricky, we typically will bring a high-powered LED flashlight to the task, and that makes a big difference. Okay, so you can see that this part here doesn't have an orientation. Sometimes they do. Sometimes there's a key on one side, so pay attention to that. There's no key here and there's no key here, so we're good there. Here's our contact rocker for each side of the switch, and everything looks really nice and clean. And it looks very clean in here. Let me show you. Let's see if we can get some light in there. In fact, Charles is going to go and grab us a spotlight and we'll be right back. Okay, so we have a remote spot on the interior here. So you can see here, we've got the common. That's where this rocker sits. And we've got the poles at each end. And you can clearly see how we basically have two switches. There's a switch, and they're basically ganged together, right? And you can see the rivets that carry through. So those rivets meet up to these contacts. Now, these can be solder tabs in which there's a smaller hole, and you take your hookup wire and you solder it to it. I like to use screws because I really like the idea of the switch being able to be removed and serviced easily. If you solder it, it's not so easy to take it apart, and you could easily damage the contact. Now, one of the things that I like to do with switches is to check the metallurgy, just so that I know what I'm dealing with. And here, I don't have I do not have any ferrous contact. There's a magnet on the end of this. I use these screwdrivers constantly on the lab bench. The batten has got some ferrous metal in it. It may be stainless or it may be chrome plated steel. It doesn't matter. That just makes for a very strong assembly. And at this end here, we've got a plunger and we've got a spring, and I've got the missing one right here stuck on my finger.
Yeah, so be careful with that. Those little springs like to disappear. Same with the plungers themselves.
Yeah.
Especially whenever they have a little bit of sticky grease on them.
So you can see here that this maintains pressure and everything is moving nicely. What about the rest of the body? We're not magnetic here. We're not magnetic in here. So that's my preference, but an awful lot of components are magnetic and will have some ferrous contact. In fact, one of the biggest surprises we came across just recently, this last month, is that the leads on our high quality Vishay capacitors are a 3-part piece of metal. So at the core is a piece of steel wire. Mm-hmm. Wrapped around that is a copper jacket. Wrapped around that is a nickel plating?
No, tin plating.
Tin plating. And I couldn't believe it when I read it. But, you know, the capacitors are fabulous in service, and we did some research, and it turns out that's very common for capacitor leads to be done that way.
Not just capacitor leads, but a lot of components. And they do it for the mechanical strength of the connection because it's more durable than just pure copper or some other alloys. It'll withstand a lot of vibration and movement, but it still has reasonably good conductivity thanks to the copper and tin layer.
Yeah. Okay. So now if your contact surfaces were magnetic, that doesn't necessarily mean it's a bad switch. With switches, one of the biggest problems that pretty much everyone that uses them is faced with is that you have to substantially trust that the manufacturer met their own specifications. And in this case, this switch is rated for 15 amps at 250 volts. Can you see that? It's right on the side. Sometimes it's on the body. Sometimes it's in a data sheet. And I'm having trouble reading that. 20 amps at 125 volts.
Yeah. Now that's AC, not DC. The DC ratings are always lower.
Usually, but we were just looking at that little micro switch, and actually they gave the same rating for the AC and DC.
Yeah, which is interesting.
It's a very low-powered switch. As the power increases, the ability to switch DC and AC do change. And in fact, I'm going to sketch you really quickly why that is. Okay, so let's just see if we can draw this out. So let's draw a DC voltage, and I can't.
That's very detailed.
I can't. You want to draw it? And let's draw an AC sine wave on top of that. Right? So, right now, if we were passing, let's say, mains voltage, 120 to 240 volts, we can see we've got a sinusoidal wave. That's our alternating current, right? Now, we've got 0 volts is right here, at this point here. And we've got, at the top here, we have our peak volts right here. And we have our peak volts right here. And the power of the AC sine wave is actually not here, but it's up in the shoulders here. This is where we've got the juice, is right in this region here and here. That's maximum power. So when you hit a switch, this thing is cycling at 50 times a second or 60 times a second, right? It's alternating. And when you hit a switch, you don't know exactly at what point your contact is going to meet. You could be here, in which case you're really not passing any current at all. But you'd have to be really lucky to hit there. But at the maximum power curve point, you'd also have to be very unlucky to hit there, or lucky, depending on what your goal is. So most of the time when you're switching AC, or let's say on average, you're not switching at the peak of the power curve. So you're not having to, the switch is not having to handle the maximum rating of the actual circuit or the draw of the circuit. With DC, you don't have any of that luck. So
It's always passing the maximum amount of voltage.
that's right. So let's draw some voltage above zero up here. So here's our DC line. It doesn't matter really what that is. It just gives you a good indication. If we're switching this on, we're on at full voltage and full current of the initial draw. Same here. It doesn't matter where we're switching on. So that's why switching DC and AC is different. When you're in really low signals and voltages, it really doesn't, it's not going to matter very much, because the switch most likely will be well over spec from what you actually are switching, especially when you're switching an audio signal. But there's always exceptions to the rule, so always check your data sheets, always check your circuit. But anyways, that gives you an idea of the challenges of switching DC versus switching AC.
Yeah, and this actually affects the switch, because if you are switching at the peaks, or if you're switching a DC signal and there's current or high voltage going through it, it degrades the contacts ever so slightly whenever that happens.
And that brings us to this part of the episode.
Yep.
So if a switch has been on the shelf for an awful long time, there may be some oxidization on the contacts. And that will need to be cleaned off. And if the switch has been in service for any length of time, it may well also have, it may have some pinpoint contact damage from snapping, basically. So everything has to pass through that contact in that instantaneous moment when the contact hits. And that leaves a little trace of damage. There's a mini arc, very tiny, very short duration. So you might end up developing a little pinpoint here and in here, not so much on the rocker area, and that can build up over many, many cycles. So switches typically are rated for so many duty cycles. And what that means is, if it's rated, let's say, for 10,000 duty cycles, that means that you can turn it off and you can turn it on 10,000 times. And at that point, the switch has met its specifications and it could well be ready for replacement, or if you can service it, to service it. Now, if you do service a switch, make sure you unplug all the power sources that are plugged into the piece of gear. Discharge your capacitors. Caution everyone, capacitors can have lethal voltages present. If you don't discharge them, you could electrocute yourself and kill yourself.
Yep. Same for AC mains voltage. Don't touch live AC mains voltage.
Okay, so what do we do? Well, there's lots of different ways to clean up this surface. What you don't want to do is attack it with a very aggressive piece of paper. So I've got on my bench, I have always a selection of sandpaper. This is 120 grit open coat. That is great for cleaning up something really coarse and messy. It's the wrong grade of paper to be using to clean up contacts, because what you'll end up doing is you'll clean off the surface. If it has a protective plating on top, you'll take that off too. You'll scratch it, so you actually won't have very good contact anymore. So about the coarsest that I use is 400 grit black paper. And another way of doing this is with a wire wheel. And I'm just going to hold this and zip this with the wire wheel and show you. Take a look at that. It's perfect. It only takes a second. These wire wheels that we use in our Dremels, we use them for cleaning tube pins and contacts like this. And, it's got a little bit of grit in a piece of plastic, and they just work brilliantly. Now, what if you don't have a wire wheel? Well, you could take a little bit of 400 paper, and you really don't want to be touching. Once you start cleaning up, you do not want to put your greasy fingers all over the contact surfaces. So start holding it with a tool, and you can just come in quickly and gently. Make sure you stay on the flat. So if the contact area is flat like this, you don't want to start coming in like this on an angle. You want to come in flat, and you don't want to put too much pressure. You just come in and you just quickly zip it up like that. And Bob's your uncle. The contact is pristine. What about where the rocker goes? Do we do anything with that? Yeah, absolutely, because that rocker is actually making contact. So we're going to come in and we're going to just very gently clean that up.
Yeah, now it's going to degrade a lot slower than the other contacts because it's always touching. And so it shouldn't have anywhere near the same amount of buildup or damage on it. But it can develop an oxide layer.
What about inside? Now, let's get that spotlight going
Okay.
again. Now, this is a fiberglass metal cleanup brush. They're really commonly available, and any metalworking supply or DIY warehouse type place will have these, and they're even available on Amazon.
Yeah, they're commonly called scratch brushes if you're trying to look them up.
Yeah, and what it is a whole pile of nasty, itchy fiberglass rods that are all in a tube like a pen tube. They come in different sizes and different coarseness, and these are great for getting into something like this. So you can get into here, and you can't see it, but I'm just massaging the contact.
Just pretend it's a Q-tip and just rub it over the contact surface a little bit.
Now, because the switch is not sentient, we're not going to hear oohs and ahs from it. But look at that. Just a quick little bit, and it's already starting to clean up. And I'll do a little bit more. I would come in here, I'd do this, and I'd do that, and of course I'd do the rest. And I'd start to renew the contact surface. Now, if it's got a little bit more corrosion, you might need to start with something like some 400 paper. How do you get in there? Well, you just take a little slot screwdriver.
Or even a little piece of wood or something like that, or a spudger tool.
Yep. And you just come in and you just do it like this. And you just work it there. And on the rocker area, I'm going to come in there. It's hard to show you, but I'm going to come in there. I'm just going to lightly clean that up. And Bob's your uncle. Everything is looking really good. Now, what about putting anything in there to help prevent future corrosion issues? Well, I'll be right back, and I'll show you what to do. Okay, so this is red deoxit. It's just a standard contact cleaner. It's also got a preventative in the formula that helps keep it from deteriorating, or from the contacts further deteriorating in the future. The thing about using this as a contact cleaner and preventative is that you have to use a very small amount. So what you do is you just come in and put a little dab on all the contact surfaces. And you could set it aside if you want and go and grab a coffee or do a washroom break. It doesn't take long. Now, here's the important thing. You can't leave a lot of that contact material in the switch, or it's actually going to help interfere with the contact. So just get a Q-tip and just lightly clean up those surfaces.
We're just leaving behind a very thin film on top of them.
Now, you can see here on the Q-tip, I pulled almost all of that up. When you put this back together again, if the original lubricant is really dry, you can clean that off with a Q-tip. And if it's just a little bit short, you can come in and you can lube that up. And I'm going to show you how to do that in just a second. Okay, so this is a multi-purpose synthetic lube. I use it on my reel-to-reels. I use it all over the lab bench, and it's fantastic stuff. It's really good stuff. It's not cheap, but it's well worth the money. Now, if you wanted to renew a little bit of that grease, you could either clean it up or you could just add a little bit more. And you just put a tiny little drop in the middle like this, and that's it. You call it good.
Yeah, not on the contact pads.
Yeah, in fact, that's a very good point, Charles. The one thing that we have to do as we clean up and put our deoxit on it, deoxit's not absolutely required, or another contact cleaner. If you using very fine abrading methods, like I just showed you with the black sandpaper at 400 grit, or the fiberglass scratch brush, that will give you a very good clean contact without the deoxit. The deoxit may help as a preventative in the long run, but it's absolutely not required. And in some cases, it may not even be a good idea. So, especially if you put too much in, you actually do more harm than good. So you've got to be very, very sparing with it. So let's put this together, and then we're going to I'll show you how to test a switch. Okay, I'll be back in just a minute. Okay, so we're all cleaned up. We're going to do a little tiny dab with our cleaner. A little dab will do you. And I'm going to do the center contact area as well. Sorry if I didn't get all of that on camera. It's tricky. Charles has got his hands handy. So now I just let that sit for a minute, and then I'm going to come back in and I'm just going to clean that. I'm going to clean that. Clean that. And actually, I noticed a little bit of dirt in here, and I'm done with this pretty much, so I'm going to get in there and clean that off. Now, we don't want to touch our contact surfaces. I've cleaned the pinpoint contacts, or the pads, and I've cleaned the center area here. And I'm working on a clean, as you can see, I'm working on a clean sheet. So I'm going to just pick that up. I'm just going to lay it right in there. And hopefully it'll land, and it did. And I'm going to do the same with the other one. Sometimes these rockers are oriented, so make sure that when you take it apart you make a note, but in most cases they aren't. And sometimes you got to get in there and you got to just do a little wiggle, and then you got them both in place. Now I chose to clean off that grease, and I'm going to renew it. So I'm just going to put the tiniest little dab in the middle here. A little bit there, a little bit there. What you don't want is so much grease that it works its way into the contact area, and then of course it's just going to cause all kinds of electrical problems. So I'm just going to lube this up a little bit. And we're just going to check and make sure the springs are all nice and free, and they are. This is really important. This is what applies the pressure of the switch.
So you got just a little bit of something sticking off of it there. Trying to make sure these rockers are clean. There we go.
Okay. There's no orientation, though, as I mentioned before, there's sometimes a little key on one side, and you have to get that in the right spot. And now the tricky business. Let's see if we can get it to go. So what I've done here is I'm just getting the one side close to being on.
And pressing down the internal lever so that it keeps those two rockers in place as well. You don't want them falling out as you're assembling it.
No. And I'm going to do this live on camera so you can see that it is slightly fussy. So I'm going to get that up a little bit so that it goes on, and then of course the other side pops off. But we can get that on. Okay, we're close, we're close. Okay, now Charles is going to come along, and what he's going to do is he's going to use the butt of that screwdriver, and he's just going to press that down while I hold everything. You're going to need a helper, I think. I've done this on my own, but...
There we go.
Okay, that started. We'll finish that in a minute. Let's go to the other side. And I'm going to hold it down, and he's going to press that on. Okay. Now before we finish that, we're going to check to see if we got free action, and we do. And now I'm going to come along and I'm going to actually work that on harder, because you don't want the switch body blowing apart while you've got a live circuit, right? This is really important. So you've got to make sure your switch is back together properly. And we're going to actually test it in just a minute. And that's looking pretty good. And it's on nice and solid.
Make sure you take a look around the edges here so that you're not offset or lifted up on one edge. That's especially relevant for the ones that are keyed, because you can put them back together. You can force them back together in the wrong position. Ask us how we know. And, and the key, if the key's not lined up, part of it will be pushed up.
Okay, now we've got one more contact surface that we haven't even talked about. So we have these here on the outside. You could take a little bit of isopropyl alcohol, because one of your enemies you got to be really careful of is surface grease. So 99% isopropyl alcohol is on both of our benches, and we use it constantly. It evaporates very quickly, so you can come in here and you can just clean up your contact surfaces and then come back with a nice dry part of your rag and clean it up. You could also come in with a wire wheel like this and just give it a quick zip.
But you have to be careful. But you have to be careful about taking off any tinning layers or anything like that that are protecting you from developing an oxide coating.
That's right. So don't be very aggressive with that. This wheel is a very low grit, and if we were to keep the wheel on, we could probably eventually carve the metal right off of this thing. So you don't want to do that. Okay. So let's just clean up here, and I'll come back and I'll show you how to test a switch. Okay, so we've pretty much renewed all the contact surfaces. Go ahead and grab a multimeter and get it in the ohm function. You can even test it. I've got a couple of clip leads here that are really handy to use. And we're seeing 0 ohms of resistance. Well, let's see. Let's stop moving around. There we go. When you get to sub 1 ohm of resistance, even just wiggling a contact can change things. So let's go ahead and clip one lead on to the common, and one on to one side, or pole here. And you can see the batten is actually pointed this way, so the switch is off, so we're not seeing any reading. Let's go to the center détente position. And we're not getting any reading. What if we go over here? And we're getting 0 ohms, 0.1. And it's wiggling around because it's somewhere between 0 and 0.1. There's no such thing as a switch with perfect contact. There's always going to be a small amount of resistance, but so long as it's very, very low and you're not switching huge amounts of current, you should be just fine. What about the other side? Let's check that. So this is the other half of the switch, right? And we're perfect, but we know we're not perfect, because if we were to put a 6-digit or even a 5-digit meter up, we would actually see that we have some resistance showing. But again, it would be very, very low, and that would be fine.
What you don't want to see is something above an ohm on there. That's whenever you know you're having some sort of contact issue.
Yeah, I would say 0.1, 0.2 is fine, but above that, you know your contacts need to be renewed or the switch is defective. So let's try the other side, and we're at 0. And let's try the other side of the other side. Is that a good description or what? Everybody knew what I meant though, didn't they? And there you go. So, and we can even test to see if the switch is functioning, and it is. As these switches may look clunky, they may look like they're incredibly overrated for switching an audio signal, that the reason we use them, first of all, is because they're renewable. You can actually carefully take this apart. You can take this apart probably 10 times if you're careful and renew it. And the switch doesn't need to be replaced. It just needs to be serviced. And that's a wonderful thing. When I was a young lad, we serviced everything. You know, if the mixmaster died, it went to the service depot. And every major town and city had at least a service depot, if not multiple ones. And parts would be ordered and units would be renewed. Today, we live in a substantially throwaway society. And one of our priorities with our kits has always been to make them serviceable so that they can last for a century or more with proper care and a little bit of renewal occasionally.
And in the unlikely event that one of these switches does outright fail, it's replaceable on its own as well with another unit.
Yeah. And one of the advantages to using a heavy-duty switch with large contacts that's designed to switch a lot more voltage and a lot more current is that you get a very low resistance contact surface. Mm-hmm. And we don't have the micro switch here anymore, but you can imagine that the micro switch, that the designers would have had to have put an enormous amount of work into making sure that the very small contact surface that they have would be a perfect contact. And in fact, the contacts are gold-plated. Mm-hmm. And that's for a very good reason.
Yeah, and they have copper alloys, gold plating, phosphor bronze. They've thought very carefully about the metallurgy that went into that sealed switch to make sure that it would last as long as possible.
Yeah, and it probably has an excellent number of duty cycles on it. Charles is actually in the data sheet right now, and it's got 100,000 minimum duty cycles.
A full back and forth, on, off, on.
Yeah, so that's pretty impressive. And under other conditions, they're saying you can get at least 50,000 operations. So yeah, it's a brilliant switch. And if they made larger versions of that for point-to-point wiring, I would absolutely be buying them. But these are a good, affordable alternative. You can see that you can renew this thing. You can get, if your audio is going through a switch like this and you haven't renewed your switch, then yeah, absolutely. Tear it down gently, and renew the contacts, and you might be rewarded with better sound. And the weird thing about, well, I shouldn't say the weird, but the truth about sound degradation is if it sneaks up on you very, very slowly, day after day, week after week, you may not notice until one day you kind of come out of your daze and you think, wait a minute, this doesn't sound as good as it did 3 months ago.
Mm-hmm. And then you test your switch and you find that you've got some resistance.
Well, it could be anywhere. It could be in your patch cords.
Yeah.
It could be the tube pins. That's a very common problem. All these things that have contacts all need attention. If you're an audiophile, if you really care about the sound quality, and in the case of switching high voltage and high current, of course, it's a safety issue as well. So it's good to make sure that your switches are working properly and are serviced or checked at least to make sure that the contacts are not showing significant amounts of resistance. Well, hopefully that helped everybody out. This is Jim.
And Charles.
From Mellow Amps, signing off. Cheers, everyone.